Students, this is the third class of antimalarials. Already in two classes we have seen what is malaria, like the life cycle of malarial parasite, the classification and site of action of antimalarials, and the chemistry of quinine. So in this class we'll see 4 aminoquinolones. In that we'll see chloroquine, hydroxychloroquine and amodiaquine. We'll see one by one. Students, now we'll see the next drug that is called as chloroquine. So it is coming under 4 aminoquinolones. Already we have known the structure of quinoline. So this is the structure of quinoline. What is quinoline? It is a fusion of benzene ring with the pyridine ring. So that can be called as quinoline. So in the fourth position it is having NH, that is amine. That's why it is coming under 4 aminoquinolones. So we will see the structure of that. So first it is having a 4 aminoquinolone nucleus. With the amino group it is attached with CH3, CH2 3 times, N C2H5 twice. Okay, and in the case of quinoline we have a chlorine. So we'll see the chemical name. So for the chemical name, first we have to choose the parent. Here that would be the quinoline. So this is the quinoline. Okay, so in the quinoline what is attached? In the 7th position we have chlorine. That's why 7-chloro. And others are attached in the 4th position of quinoline. That's why it is 4 open bracket, and here this is having 4 carbons. Here 1, this is 2, 3 times, no, so 2, 3, 4. So 4 carbons are there. So 4 carbon alkane can be called as butane. So that's why it is butyl. So with the butyl, what is attached? Here we have a methyl group in first carbon, so 1 methyl, and in the case of 4th carbon what is attached? This is called diethyl amino, 2C2H5, that's why diethyl amino. So diethyl amino group is attached in the 4th carbon, and in the first carbon we have a methyl, and this is butyl. Here we have aminoquinoline. So what is the chemical name? 7-chloro, here 4 for this quinoline ring, 4 open bracket, again 4 for that butyl. So this is butyl, no, 4 carbons, that's why 4 diethyl amino, 1 methyl, this is called butyl, here aminoquinoline. So that is the chemical name of chloroquine. Now we will see the synthesis of chloroquine. There will be 3 steps for this synthesis. Now we will see one by one. So we will see step 1. Step 1 is preparation of 4,7-dichloroquinoline. For this, here we have taken the parent as metachloroaniline. Already we have known what is aniline. Aniline is a benzene ring with NH2, that can be called as aniline. This is ortho, this is meta. So in the meta portion chlorine would be attached. That's why it is called as metachloroaniline. So that one is treated with formic acid. Already we have known the structure for formic acid. What is that? HCOOH, that is formic acid. So by the addition of metachloroaniline with formic acid, what happens? Here we have H, no, this H combines with this OH and removed as water. So here we have only NH. So in this position we have NH, and here we have CHO. So this CHO has combined with NH. So that's why we are getting this one. So we are getting NHCHO. Now with that, again we have treated metachloroaniline. So by this addition what happens? Here we have oxygen, no, that oxygen combines with these H2. So 2 hydrogens and removed as water. That's why this carbon has to connect with this nitrogen by means of double bond. Why there may be a double bond between these two? Because here oxygen is connected to the carbon by means of double bond, and here 2 hydrogens are removed from nitrogen. That's why this carbon and this nitrogen would be connected by means of double bond. That's why we are getting this. Now with that, here we have added diethyl malonate. Before that, already we have known this is called as a malonic acid. What is malonic acid? CH2COOH. So it is a dicarboxylic acid. So what is malonic acid? In center we have CH2 and 2 ends are connected by means of 2 carboxylic acid groups, that is called malonic acid. So we are getting ethyl esters, means here we have ethyl, instead of 1 nitrogen here we have ethyl, here we have ethyl. So this is called as diethyl malonate. So with this, here we have added diethyl malonate. What is that? CH2 COO C2H5 twice. So we have added this one. So in this addition, here what happens? With the carbon it is having 2 hydrogens. No, that 2 hydrogens
coming here and attaches with the nitrogen. Because of that there may be a cleavage here. So, if it is cleaved, this would be going. So, benzene ring, here NH2, here Cl. So, the metachloroaniline is going. So, with the carbon, here we have CH2 and here we have double bond. So, that is connected with this carbon, and carbon is connected with COO C2H5 twice. That is why we are getting this. So, this is a diester. So, this on cyclization what happens here in this carbon, here we have hydrogen. No, that hydrogen combines with OC2H5, removed as C2H5OH. So, that is why this carbon has to connect with this carbon. There may be cyclization. So, if it is connected, here we have CO. So, in that N, here we have CO, and that is a keto form. So, again that will be converted to enol form. So, we are getting OH here. This on hydrolysis what happens, here we have ester. No, already we have known ester. On hydrolysis we are getting acid. That acid on decarboxylation, here simply we have hydrogen in that place, that carbon dioxide also would be going, and we are getting this one, that is called 7-chloro-4-hydroxyquinoline. This on chlorination by means of POCl3, OH is replaced by means of Cl. So, that is the step 1. So, what is that? We are getting 4,7-dichloroquinoline. Second step is preparation of 4-amino-1-diethylamino-pentane. For that, here we have taken two starting materials. One is ethylene oxide, another one is diethylamine. So, what is ethylene oxide? CH2, and that two CH2 are connected with oxygen. So, here by the addition of diethylamine, what happens? Here there may be a cleavage between carbon and this oxygen. So, on that cleavage what happens? Here that hydrogen, no, that is combining with this oxygen, this oxygen, and the left N C2H5 twice, no, that is combined with this carbon. So, like that. So, this is called ethylene oxide. With the ethylene oxide, here there may be a cleavage, H is added with oxygen, and N C2H5 twice is added with the CH2. So, that is why we are getting CH2O N C2H5 twice. Now, this on chlorination we are getting chlorine, in the chlorine, that is replacing OH. Okay, so we are getting chloro derivative, and that one is treated with CH3CO, CH2, COO, C2H5. So, before that we have known CH3COOH is called acetic acid, CH3COO, C2H5, this is called ethyl acetate, and here instead of one hydrogen we are adding CH3CO. So, that is called as ethyl acetoacetate. So, what is ethyl acetoacetate? CH3CO, CH2, COO, C2H5. So, with this we have added ethyl acetoacetate. So, on that addition here what happens? Here we have with the carbon, here we have two hydrogens. No, one hydrogen combines with Cl and removed as HCl. That is why this carbon has to connect with this carbon. That is why we are getting this one. So, already here we have CH2. So, CH2 N C2H5 twice, that is CH2 N C2H5 twice, and here we have CH3CO, one hydrogen is already went, that is why CH CO C2H5. So, that is this one. So, this on hydrolysis what happens? Here we have ester, no, ethyl ester. So, that would be hydrolyzed, we are getting only acid. So, on hydrolysis COO C2H5 would be converted to acid. Now, this on decarboxylation what happened? This carbon dioxide is also going, and here we have only H, that is why this would be converted to CH2, that is why totally 1, 2, 3 CH2. So, we are getting CH2 thrice. So, we are getting this one. Now, this on reduction what happens? Here we have a ketone, no? So, that will be reduced to secondary alcohol, CHOH. So, how we are getting that? Already we have known primary alcohol on oxidation. So, primary alcohol on oxidation we are getting aldehyde on oxidation we are getting acid. So, secondary alcohol on oxidation we are getting ketone on oxidation we are getting acid. So, the reverse, acid on reduction we are getting ketone on reduction we are getting secondary alcohol. That is why here we have ketone, no? So, this ketone will be reduced and we are getting secondary alcohol. Now, this on amination by means of ammonia, instead of an OH, here we have NH2. So, here H with OH removed as water, and the NH2 would be added in that place. That is why we are getting this one. This is called 4-amino-1-diethylamino-pentane. So, here, so how it is getting the name? So, it is having 5 carbons, that is why it is called pentane. So this is called first one. 1, 2, 3, this is 4, this is 5th carbon. So with the 4th carbon we have amino group, and with the first carbon we have diethyl amino. So 4 amino, 1 diethyl amino, this is called pentane. So that is the step 2 product. Now third step is condensation of step 1 and step 2 products. So on step 1 we are getting 4,7 dichloroquinoline, that one is treated with 4 amino, 1 diethyl amino pentane. So on that addition what happens, this Cl combines with H from here and remove as HCl, that is why this NH has to connect with this carbon. So that is all. So the left is the same. So we are getting chloroquine. So that is the synthesis of chloroquine.
Chloroquine is available in phosphate and hydrochloride form. This phosphate form is used in oral preparations and hydrochloride form is used in parenteral preparations. This is used for the prophylaxis and treatment of malaria. Now we'll see the adverse effects of chloroquine. They are retinopathy, hemolysis, in patients with glucose 6-phosphate dehydrogenase deficiency, muscular weakness, exacerbation of psoriasis and porphyria, and impaired liver function.
So next is hydroxychloroquine. Already we have known the structure for chloroquine. So this is hydroxychloroquine. From the name itself we can say there may be addition of one hydroxy group to the chloroquine. Okay. So already we have seen, so this is the structure of chloroquine. So what is that? We have a quinoline nucleus, and in that 7th position we have chlorine, and in 4th position that is connected with amine. That amine is connected with butyl group, and with the butyl group first carbon is connected with the methyl and 4th carbon is connected with the diethyl amino group. So that is the structure of chloroquine. So what is hydroxychloroquine? Here we have nitrogen, no? So the nitrogen is connected with the 2 ethyl groups. So here, so if the nitrogen is connected with the 2 ethyl means that is called chloroquine. So here 1 ethyl is having hydroxy. So nitrogen is connected with one ethyl group, another one hydroxy ethyl means that is called as hydroxychloroquine. So here in the case of one ethyl, one hydrogen is replaced by means of a hydroxy group. So that is the structure of hydroxychloroquine. So now see the chemical name. So same as that of that. Here in that name, here we have written 4-diethyl amino, no. So instead of 4-diethyl amino we have to write N-ethyl, N-hydroxy-ethyl. So what is the chemical name? So 7-chloro, 4 open bracket, in that again 4. 4 means because of the butyl, 4th carbon of butyl, that is why 4 N-ethyl, N-hydroxy-ethyl, close the bracket, 1-methyl, this is butyl amino. Butyl amino, this is quinoline. So that is the chemical name of hydroxychloroquine. Next drug is Amodiaquine. So it is also coming under 4 amino quinolones. So here it is having quinoline nucleus and that is connected with amino group. That is why it is coming under 4 amino quinolones. So here we have quinoline and 7th carbon is connected with the chlorine and the 4th carbon of that quinoline will be connected with NH. So this one, no, already we have known, this is called aniline. What is aniline? Benzene ring with NH2 can be called aniline. So with the aniline, 4th carbon is connected with hydroxy group and 3rd is connected with the diethyl amino methyl group. So now we will see the chemical name. So for that we have to choose this as a parent, that is quinoline. In that 7th carbon is connected with chlorine, that is why 7-chloro, 4 open bracket, in the 3rd, no, with the 3rd what is attached? Diethyl amino methyl. So 3-diethyl amino methyl, 4-hydroxy anilino quinoline. So if you are writing aniline, if you have taken aniline means we have to write this chemical name, or we have chosen this phenol, no, phenol as a parent means we have to write. So for the phenol, this is first carbon, this is second one, this is third, this is fourth. So with the 4th carbon amino group is attached and with the amino group quinoline would be attached. Now we will see the chemical name of Amodiaquine by means of a phenol. Okay, so with the phenol, so this is phenol, it should end with phenol. So with that 4th carbon is connected with amino group, with the amine only quinoline would be attached, that is why 4 open bracket. So here we have 7-chloro quinoline 4YL. So 4th position of quinoline would be attached, that is why quinoline 4YL. Here we have amino and according to phenol this is second carbon, that is why 2-diethyl amino methyl then phenol. So, that is the chemical name. Now, we will see the reaction of amodiaquine. This amodiaquine, no, that on oxidation we are getting amodiaquine iminoquinone, already we have known. So, this is called hydroquinone and here we have nitrogen. So, that can be called as iminoquinone, we are getting iminoquinone derivative, that is also it is very toxic. So, what you are getting on oxidation, this is amodiaquine. Amodiaquine on oxidation we are getting amodiaquine iminoquinone. If it is used for the prophylaxis of malaria, there may be higher incidence of hepatitis and agranulocytosis. Already we have seen it is oxidized to amodiaquine iminoquinone and leads to amodiaquine toxicity.